Hi everyone, welcome to Unreal Fest 2022. Very nice to see you all. I hope you're enjoying this lovely in-person event, and I hope you've enjoyed some beignets. If you've been in New Orleans before, fantastic deep-fried food. Please go find Café du Monde if you get a chance. But we are here to see Unreal, so let's show it off. So what we are going to talk about today is advanced UI templating techniques. And I don't know what to say. If UI is the last session of the day, maybe it's how we all feel about UI sometimes. Always thought about last, but we know that it's most important in our hearts. And who's presenting this talk today? My name is Adrienne Pugh. I'm a UI technical design director at Epic, particularly working on Fortnite. And my invisible colleague right next to me, Pavlo Gruby, he couldn't make it here today, but you will be seeing him very shortly in this presentation. So what we will cover, we'll want to cover some styling with widget inheritance. We want to cover some layout templating with name slots, visual styling with material instances, and more stuff about materials, animating with curves, and animating inside of blueprints. Now, something to note, at Fortnite, we use materials a ton in our UI. It is the clutch of how we develop our UI. So we want to show you some of these techniques, and we also want to show you something that we literally have put in and maybe started prototyping about a month ago, which is our last point, which will be the smallest bit, because it's not polished yet. But we want to show you some of the ways that we're incorporating materials and blueprint triggering at the same time. So let's get into it. What are we actually going to show here today? We built you a lovely little card deck simulation. And this includes on one side you have your actual cards, and on the other side is the deck building aspect. And we thought this would be a great way to indicate essentially the same data that needs to be styled differently across multiple cards and have more information in different contexts. So we thought that this was a great example to give you that idea. And rather than just show you, let's actually get into Engine and see it in action. I'm sorry, everyone, I'm so short. You're not going to be able to see me over the monitors, but I'll try to do my best. So here's sort of the prototype in action. We've got the deck card building side here over on the right, and then we actually have the cards over on the left-hand side. And we've got a focus state, so a press, and we've got a nice little hover animation. And what we're going to be showing you is the techniques that we put this together with. You notice that we actually have different idle animations for each individual icon, and we've got different styles here. This is all basically done with materials and a couple of widgets. So let's break down what we're doing here. If I go back to the presentation. First topic is styling with widget inheritance. So widget inheritance is essentially allowing us to override various properties that we put in our parent widget that we want the child widget to change. And we basically use this concept to change from what our base widget is to style the card differently in different contexts. So in this principle, we're basically making a responsive layout. We're parameterizing those widget properties, inheriting from that, and then blowing all those properties up with whatever we want in the children. So to introduce this concept to you, and this presentation is actually all of Pavlo's idea, I want to introduce my colleague Pavlo, who couldn't make it here, but here he is today.
Dobry den, everybody, and thank you for joining us at Unreal Fest 2022. My name is Pavlo Gruby. I am a technical UI design director on Fortnite. First of all, many thanks to Adrienne Pugh for presenting these concepts and techniques today. I will guide you through styling with widget blueprints and inheritance. Here on the left, you can see the card-based widget, and on the right is the widget inherited from the left one. We will try to make the widget on the right to represent the details of the card. First of all, imagine that you are a web developer working on a responsive website. You have a good old browser with CSS support, and all you need is to define another style for your content. Let's start from the size of the card. At the root of the widget hierarchy, I put a size box, which allows me to define the size of the widget. If we want to make another style, we should parameterize the width and height of the card. Let's add two float variables, one for width and one for height. We want to keep things tidy, so let's make a category for them. After compilation, we can set the default value of the variable. Now let's use the default values to set actual widget properties. Event preconstruct is executed in editor on any change, so it is easy to see the result straight away. We want to keep our blueprints tidy, connections straight, and reusable logic collapsed to functions. Now let's revert our default values for the base widget and change the default values for the inherited widget. The next thing we want to style would be the icon size. When increasing the image size, Wrapbox pushes the content that doesn't fit to the new line. The easiest way to achieve that would be to parameterize the icon brush. We also want to have ability to swap the icons for different cards. Another variable of texture 2D type would serve that. The icon will look nicer if scaled down a little. The icon material supports scaling, but we should provide the value for the corresponding material parameter. Again, we can set the default values of the variables after compilation. Let's quickly throw a bunch of setters in the blueprint. Now we can change the default values of the inherited widget to make it look as we want. Don't forget to revert the default values of the base widget. Next thing to modify would be the header text style. Let's collapse the icon related blueprints into the function to keep it tidy. A variable of slate font and font type would be able to handle all the font styling parameters. And again, let's set the font of the text block on preconstruct with the default values from variable. In order to change text alignment, we should modify text justification. A variable of eText justification type will help with that. Now let's modify the default values in the right widget blueprint. The last style in touch would be to increase the size of the mana cost element. A scale box will help with that. Again, collapsing the previous work into the function. Now we need a float variable to drive the user-specified scale. Adding another setter on preconstruct to assign the default value of variable to user-specified scale, and changing the default value on the derived widget blueprint. And here is the result. So far we modified the card size, the icon size, text style, and the mana cost size. The last thing you would probably want to add is the data for the card. We want to be able to set up the header text and mana cost on the widget instances. By the way, we already have a variable for the icon texture, which is also related to data. And again, setters on preconstructs for text blocks. Finally, set in the default values for the derived widget. And here is the final result. Thank you very much for your attention. Stay with us and there will be more exciting stuff from Adriana next.
It's good to play again. No. But yeah, thank you, Pablo. So I'm going to just quickly summarize what it is, and then we'll get an engine and do it ourselves. So essentially, we've got everything wrapped around with the wrap box, meaning anything that overflows will go to the next line. This will allow for the cards to have different designs because we can decide to push the content to the next line. Then we parameterize those properties we want to control, as Pablo showed. We make little functions that we want to set those in. We inherit from our base widget blueprint, basically can create our widget. So let's go into what that actually looks like. So I'm going to go into our lovely project here. I'm just going to make a new widget blueprint. I'm going to inherit from the base card. All is the same, WBP underscore card demo. And voila, we have a card right on here. And you can see it's inheriting from our base. We can go in, we can edit the parent. All is well in Unreal Land at the moment. So if I want to make another instance of the card, let's say I want to make a tall and skinny card. So I'm going to set my width to 256, my height to 768. I want my icon size to probably fill to the next line, so I'm going to set it the same as the container. And my icon height, let's set it the same. Now the size itself is a little, flush, so let's unflush it, give itself a little bit of space. And let's do the mana cost as well. Let's scale it down. Let's make it a little adorable at 0.7, so it's really cute all up there in the corner. And we turn off the grid, and voila. I have a new style for the card. So this is the way that we can inherit the same data, use that card, place it anywhere we might want it. And that's essentially what we did with all the other content. So these other cards are inheriting from the base card, and we add extra content inside. Spoilers, next topic. And same with this card. We expose a bunch of parameters, a bunch of properties, able to style things, and inherit from these properties to do different things. So with that, let's go into the next topic. Templating with name slots. So name slots are inherently this empty container that you can add more widgets into in other instances of that particular widget being used. Now, this is the 5.1 part of this presentation talk. In 5.1, we now have inherited widgets can actually access that name slot widget hierarchy. So now you have a way that you can templatize layouts because you have a name slot where you can change out the layouts and a lot of the widgets inside. This essentially means that you can create maybe pop-up modules, all sorts of templatized ways that you can inherit from the same widget, but see it in different contexts, see it with different visuals, and see it used in other areas. So inherited name slots, that's the new 5.1 feature, and 5.1 preview is what we're running this project on right now. So that's what we did here. We have a lovely little name slot at the very bottom. That's the green container here. We're able to style the card, as we showed before. And inside of this name slot, we can add all the extra details that we want this card to have in a different context. So this, for instance, is going to have the text subtitle and the icon and description, little header, the wavy banner. And the last little bit is then we can obviously parameterize that added content and expose it to other areas inside where we want this widget to live. So let's go in and make that right now. I'm gonna close out some extra windows because it'll be like Chrome where I have all of them open at once. We're gonna get there. It's gonna be like that. But you can see inside of our lovely demo, we have this empty name slot. So I want to add in some extra content. I'm going to put a little overlay, and Pablo used the size box. One of my favorite ways to take up space is using the spacer widget. Not spicer, spacer. And so we're going to put this in here, and I'm going to force this wrap box to wrap to the next line by making my spacer the size of the container, which is 256. So now all my content has wrapped to the next line. Now, I want to adjust the title. I'm sure it's bothering everyone else here. Let's center align that, please. All right, now we can continue now that we don't have any issues with that. So I'm going to put in a vertical box. And maybe I'm thinking about a way that this card is maybe a leveling card. So you need to have progress bars and level this card's information. So let's actually put that in. Let's put in some progress bars. Let's do one in here, and then I'm just going to duplicate, duplicate, duplicate. Let's align our vertical box to the full width of the container. Then I want to put in some padding. Let's put in a nice little 20. That's livable. We can all deal with that. And I'm going to just do a little bit of padding on the top and bottom of our progress bars so they're a little bit more legible. And let's zoom in for all the folks here. So now we have the card that has a different context of information. Inside of that empty name slot, we're able to add more information that's contextually aware of the card, but the card still has all the base card details from the parent. And so you can expand on this concept. Now, let's just add in some extra progress. Let's make it all pretty. Let's see, it's down here, percent, and I'm just gonna fill these up, make it look like something nice. So that's how easy it is. We can basically now have a lot of different card types that might have different or added contextual data, all inheriting from our base class. And you'll see that really comes in handy when we get into animations, because it's gonna animate exactly the same as all the other widgets, because spoilers, that's what we're talking about next. So let me alt-tab. Visual styling with material instances. So like I said, on Fortnite, we love materials. And we love material styles to be our style guide. So material instances essentially does that for us. So what we are going to do is we're going to make a material instance. We apply a bunch of properties that we want that instance to change. And then we have a material interface, and this is what we'll get into shortly. But essentially, we can change out a style, a color, or anything on the material side rather than doing it on the widget side. That's what we prefer to do at Fortnite. And what we mean by material interface is that in our material function, we set a number of default parameter names. And these names are going to be the same across every single material instance. And that means that if we want to animate something, we don't have to remember to put in the material, the property name. It's actually in the function itself. So here is the function we're talking about. It basically has an idle state, a hovered state, focus state, press state, disabled state, all of these states that will blend between different colors. And so when we put this inside of a material, we don't necessarily need to call out the material properties because that's all in the material function. So no artist can accidentally name it the wrong way. You can't have user error this way. And so we're keeping all of our information contained in one area that we might need to change that information to. Take a deep breath. Talking fast, folks. And what's useful there is because we can play an animation on those exact same properties no matter what widget or material. And so with the material instances, on the parent widget, we can say play animation A on hover and play animation C on child, or we could say play animation B on focus for the parent, and in the child widget, we say play animation B and D. So it could be additive, or you can negate the original animation. So we do this by first setting up a bunch of functions that play these animations inside of our parent widget. Then we have the standard buttons events, and we tie those functions to those events. So it's a one-to-one function to event. Then inside of the child widget, we can basically overwrite that function and then tack on the other functionality that we need when those events are triggered. And essentially, you get the look that we have here, which is the difference between the deck on the right versus the animation of the cards on the left. We have more detail animations happening. Also, the idle animation triggers. It doesn't trigger on the other instance, but it triggers on the child widget. So let's set that up in Engine. So right now, I'm going to go into the base card, and I'm going to show you what the animations are doing. So the animations are basically triggering a bunch of the exact same property names. Like I said, we have our material instance that uses exactly the same property names. We trigger those from a 0 to 1 lerp. It's pretty standard. So let's actually then go into the material. So we've got our background material here. I'm going to hunt down. And then here's basically those standard material interface properties that I was telling you about. So if we go into the card, they're actually hidden under here inside of this material function, this lerp function. So in here are all those properties that you guys just saw. And also, spoilers, this is for later, but that's a later discussion. So this is what's going to animate between the colors. So all we have to do, if we want to have a different visual color set for the focus, hover, press, all we have to do is make a material instance of this and plop it directly into where our card lives, because our card is only animating on these standard sets of names. So it doesn't need to have a different animation. It doesn't even need to have any different information that it basically, it's just going to run on its own. I'm so enamored, I'm tongue-tied. So let's make a material instance. MI, UI, card, all caps, background, demo. And in here, I want to switch my colors. So let's change the idle. This will be the most obvious. Let's do our lovely yellow. Hovered, let's go for an orange. Focused, I mean, we don't really show focused here, but pressed, I'll stick to around a blue over here. So we go back to our card demo. All we have to do is swap out that material with our new one. And because the animations are all going to play on the parent, all of these animations will actually work inside the editor. But let's first make an animation with something that we also want to play on top of the base animations. So I'm going to go in here, going to remove this, and actually let's start with the animation first. So I want to animate transition hovered. Let's say I want to animate some progress bars, but also what's really fascinating is you can see all the base widget, the parent widgets, widgets as well here. So you can actually animate on the parent widgets differently than you can from the child, which is actually what we do in some other instances. But let's do a progress bar, %. We are going to start at 40, go to 1, and go back to around 40.4. So we'll play this animation when hovered. So I'm going to go to the graph here. I'm going to again do the overwrite. So overwrite, I'm going to find my transition hovered. This is in the parent. And I'll just do a play animation off of this. So here we go. Here's our transition hovered. Plug it in. And of course, we need an unhover state. So let's make sure I get that. And I'm just going to do play in reverse. And the same animation is going to be in reverse. Now, all we have to do is place this into our core widget that contains all the other widgets. So I'm just going to find our card. Let's plop it on down here, tall and skinny, and cross your fingers, everyone. It will animate because all the properties are exactly the same name. They have the same material instance inside of that material function, and all I have to do to style this differently is swap out the material and make sure I'm using that material function. And guess what? It does the hover animation on top. So all of that, really easy to visually style and make different things. So that's exactly what we're doing with these two cards over here. They have a different material instance, but the functionality is exactly the same. So you don't need to worry about having new functionality. It's all exactly the same base card, one of these. So let's open up one of these widgets. And you can see the description hovered here is going to play the hover animation, but the hover animation is also going to turn on a widget that is inside of the parent. So on the image icon, we're going to animate on this idling brush material. So when I didn't mean to hit play, but that's fine. When I compile here, we're going to get a warning that says is animating on a non-existent image icon widget. And that's a lovely warning, Unreal, but actually will exist. But this is a new thing also with Unreal 5.0, is it gives you warnings when you're not animating on things that it thinks. So thank you so much, Unreal, for that descriptive detail. But don't worry, it's just a warning. We know what we do with warnings. We ignore. That is exactly what we all do here. So anyway, that's the concept with the material instances. Now, we're going to get into the next little bit, which is animating the materials with the curve atlas. And this is kind of what I was showing with the icons themselves, how the icons have this fascinating idle animation. That is actually all done with curve atlases inside of the material. And let's break that on down. So a curve atlas is commonly used in VFX and all that amazing technical art world, but we don't see them used that often in UI. So I want to open everyone's minds to curve atlases, breathe it in. It's going to be a great time. A curve atlas is basically a massive texture, and I say massive because UI is usually 64 by 64. But it's a pretty large texture that can handle any amount of rows to fill up that texture that will give you these curves. Then you can use the material instance to determine which curve you want to animate. It sounds a little bit more complicated than what it actually is, but here's this setup in the material. We have this curve, and that curve essentially has a row that will do the different animations. So here's the curve atlas texture, and that's what I'm talking about, massive, 256, makes me all excited. So in this 256, we're just filling it up, each individual row with these various curves. And then we can swap out our material instance to use whatever curve we want to get a different animation style. So essentially, you can go in and get all these different animation styles out of one texture. You don't need to run different widget logic saying play animation A in sequencer if the icon is this, or animation B. This is a really easy way that you can handle all this logic and visual styling just with material instances and not have to put that logic inside of the blueprints. And the fun thing is that you can play with curves. The curve editor is very fun. I click around in it all the time. I abuse it. And it's really responsive. As soon as you change this, you can almost see the update immediately. So it's not a bad way to work for artists to see their changes with the curve and see it almost update immediately in the engine. You don't even need to run Pi. So let's break that down for you. And so we're going to go into the icon itself. And this material, we are doing the curves. We're basically animating the idling by using the screen position and adding or subtracting our curve data to the absolute position of this widget. And so here's the curve that we talked about. So here's one of the curves, and here's the atlas itself. So I'm going to just make a material instance off of this so we can demo it. MI icon demo. Great. And in here, I'm going to zoom in. I'm going to turn the checkerboard on. I'm going to show the border so we can kind of see what's happening. And let's default the animation to 1 on so we can see what this is doing. It's actually moving out of the frame. So because that's what offsetting the position will do, is actually move it from its current position. And we can change the curves that we're using here. So I could change it to powers. I can change it to this other powers that does like more of a bob up and down. And here's like a more floaty animation, etc. So again, really easy. You could just swap out any animation style, no blueprint logic needed, just plug in the various material instance you want. Now let's go make a curve. So to make a curve, we have our curve atlas here. I'm going to go into curves. I'm going to go in miscellaneous. Curve is here, curve atlas is there. Let's do our linear curve. This could be animations demo. Now, the one thing that I'm doing, because I'm shifting the position of the icon, I want all my values to go from 0 back to 0. I don't want anything to start at 1. So we're just going to drag and move all the, wow, that has never happened. It's never been that nice to me. I've never selected all of them at once. I'm very stunned. And then the middle mouse button will add a key, or you can right click, add a key. So I'm going to add a key here, and on the red channel, I'm going to bump this all the way up to 20, because we want to move it 20 pixels. So we're no longer in the realm of 0 to 1. And if you repin it, I found that will scale it all nicely. So we've got our curve. Now we have to add it to the actual texture atlas, because it's not in our lovely texture atlas yet. So if we go to our texture atlas, our tiny little rows here, let's add another. And we want our animation demo. So that added another curve, a single pixel line to our texture. You could see how many animations you could actually store in one texture. It's quite a bit. So let's swap out this. So now we're playing this animation demo. And what I've set it up in the material is that the red channel will shift the icon over to the left, because lefts and rights are really hard for me. Bear with me. I'm going to try to be like, shift it over left. So this will shift it over to the left. But because curve atlas textures can't go negative, so instead of doing a negative value, putting out of the curve, I put the ability to shift the icon over to the right in the blue channel. So I kind of split up the red and the blue to be left or right, moving along the horizontal axis. So if we adjust, well, let's just show off the blue right now. At 20 pixels, I save this. We go back to our material instance, and you can see it's shifting the icon over to the right instead. And then guess what? You can chain them together. So sometimes it's a little difficult, so I'm going to just only solo one of these, because sometimes their keys like to overlap each other. And I'm going to go back to the red channel, put it over here, put this back, snap the grid, and now we should have a very smooth to left to right idle animation going on. But curves are not meant to be linear. Curves can be anything, so we can just literally then add easing, do all sorts of fun animations, and now that's adding an easing into our animations here, and this then simplifies it down to a texture, so you're not having that extra Bezier curves that you're reading on the GPU or any of that. It's actually all consolidated into one texture. Very cheap to run, very cheap to use, and again, you're not having crazy widget logic to get this to run. All you have to do to play this demo is we would go into our demo card, and it's not exposed in this one, it's exposed in the, I think it's exposed in the base. Now I don't remember, but in here, we can just swap out our icon material to our demo, and now it's hidden. Oh, nope, wrong one. That demo. And sometimes this doesn't update, but we'll also do it here for good measure. Ta-da! Where's my demo? Lots of demos here. Sometimes I've had an issue with these updating lately. This is just a 5.1 preview, I believe. But if that doesn't work, we can always modify another card that has it working. No, alas, alas. I was fearing this, but it's fine. We'll go into our core ones over here, and let's just swap out the potion with our demo. And we should be able to run this. And so our potion now on the hover animation, because that's when I trigger it, is doing our demo curve animation at the moment. So that's, again, a way that we can have individual icons have different animations without any widget blueprint logic overhead. It is truly just animating inside of the material using offsets. So that's also what these two are using. They're using material instances that hover up, hover down, and the same with these stars. So that is the concept there. Now let's go into The fun and final bit, animating materials with blueprints. And again, this is the most experimental thing that we have been working on. So what we wanted is we wanted to find in our material function a transition that we want to animate from 0 to 1. And then we want to essentially use the blueprint logic as if it were a play animation node to trigger all those actual animations inside of the material itself. So we're basically going to remove sequencer out of the picture and just have the material handle all of the animation logic, including a macro. So I want to give massive credit to Athena. She's a UI technical design director. She's been just kind of experimenting with this for fun on her free time. And so I'm very excited to show it to you in Engine. So what we're going to do is we're going to go into the material, which this is where I told you I was going to have too many windows open. I gotta close it down. All right, let's go into our base card material. And the spoiler that I told you about before, we essentially have this material function that animates the timer. So this says play duration, loops, play time, time direction, speed, start time. And if you are familiar with UMG play animation, these look an awful lot like the play animation settings. In fact, they are identical to the play animation settings. So we've created this macro that can basically simulate play animation without actually using sequencer, and it does all of this inside of the material itself. So if I go into this macro, it gets the material, and it will set those various parameters in the material to do all of these functionalities. And guess what? That's exactly what this material function is doing. Now I'm going to go into this. No, nobody scream. It's a little complicated. We're still working on it. We're still working out, what's the more efficient way, how many things we want. But it's still pretty impressive. We can trigger all this functionality just in the material itself, so we can pass all of that onto the GPU and not necessarily have it as extensive on the CPU. So all we have to do is move these over to our named reroute nodes, save, and go back to our card here, and we're just going to remove all of these play animations and trigger the macro instead. So that was hovered. This is unhovered. We've got pressed, and there is no unpressed because you can't undo a state of pressing. I've thought about this a lot during this presentation, just so anyone's aware. And all we have to do now is hit play, and we have exactly the same functionality here without any sequencer animations happening. So this can do exactly what sequencer can do, but it's actually inside of the material itself. And this is handy because we're trying to think of really cool animations we want to do, but in materials it's on. Either it's playing a looping animation or off. This allows us to trigger way more things dynamically in the material that we can have, say, set up to gameplay data. We could speed things up in the material or not, and have all of that be more dynamic data passing in. So that's something that we're working on. And if I go back to, I've lost my window. If I go back to the card base, so we're going to go back to hovered. Again, a great thing, we can just change the time, duration, etc. And this is all just being passed into the blueprint itself. Change it to 5 loops. And we run this. And it's very fast. Trying to do those loops. Let me see what I might have messed up. Yeah, play duration's only at 0.1 of a second, so that's quite fast to try to get 5 loops in. But at 1 second, we'll see 5 loops triggering. We can ping pong, we can do all sorts of fun things. And again, all of this is just being passed directly into the material rather than sequencer or other things. So it's just some fun visual logic that we kind of want to show with you today. And that will generally conclude this talk from standard to experimental. So thank you for joining us, everyone.